Okay, let's go ahead and get started. How's everybody doing this morning? Awesome. Gotta love this weather in Montreal, huh? This is your first PyCon? That is awesome. That was me 3 years ago, and this is by far one of my favorite conferences that I ever go to. And I am super excited to be able to help you kick it off this year. So I like to think you made the right choice this morning. So my name is Andrew Baker. We're going to be in here together until around noon talking about Docker stuff. This is going to be a pretty informal session. I have maybe about like 25 or 30 minutes of slides just to kind of get us all on the same page, but then after that, the way I like to run my tutorials is kind of writing up a whole bunch of exercises and then letting you guys go at it at your own pace so that you can make the most of your own time instead of just following along with me on the screen or something like that. So at that point, I'll be running around and helping people out, and if everybody gets stuck on something that's the same, we'll maybe stop and do a little bit more talking about something up front, but otherwise I expect this to be pretty casual. So first, a little bit more about me. I am a software developer in Washington, D.C. Python is my main gig, but I unfortunately have been working with Node lately to pay the bills. You can't always choose. I have been using Docker for maybe about 1.5 years now. I learned about it first at DjangoCon 2013, and it just really piqued my interest, and then I built my own lightweight Docker platform as a service called Spin Docker, just to really dig into it in a side project and figure out what Docker is all about. And I think it's a really cool technology, but I don't work for Docker, so all the opinions here are my own, and I'm going to try and give you guys the straight recommendations on what I think Docker is good for and what I think it's not good for, and which parts are the rough edges that they're still working on. But last fall, I teamed up with O'Reilly to do their first Docker offering, which is an introduction to Docker video, which is just 2 hours, sort of crash course on going from hello Docker to deploying a Dockerized application in the cloud. It's really, really quick, but because we are going to be in here for 3 hours, you are going to get further along than that video, so you should definitely not buy it. But maybe you have some coworkers back home. I am not the type to buy videos myself, but it is on O'Reilly's Safari service. If you work at a company where they subscribe to that, then you can look at it for free. So if you know someone down the road who is interested in learning Docker and wants to get started quick, that might be a good place to point them. Now let's talk about you guys. So who here has done the official Docker tutorial online? The one that's just in the browser. Okay, 2 people. Then these next few questions aren't going to be as interesting. So who has installed Docker on their machine before? Oh, okay, cool. And who has tried to write a Docker file for their own application before? Okay, a couple people, awesome. Then I think we are definitely in the sweet spot for this tutorial. You guys who have a little bit more experience might speed through the first stuff, but that's exactly why I try to do this in a self-paced format so that everybody gets to work on exactly what they want to work on. So today we're going to talk a little bit about sort of the premise and the promise of Docker. We're going to talk a little bit about how it works, some Docker vocabulary, some Docker history and where Docker's going, and then we'll get into the exercises, which are going to take up most of our time, and then we'll wrap it up. So who here has had to say this to someone they work with before? I would imagine most of us have experienced this. This is a really tough sentence to say because it means that someone has come to you and they are upset because something is broken, and you didn't know that it broke, probably. And now you two are having a discussion where you're trying to figure out what went wrong, but also, because both of you are human beings, you're probably in the back of your brains trying to figure out whose fault it was that something went wrong. Environment differences causing production defects just are one of the most frustrating parts about being a software developer. And Docker, when Docker was open sourced a couple years ago, they were not the first software container technology, but they were sort of the first software container technology that was trying to market to developers to solve this particular problem. So the promise of Docker is build once, run anywhere. The idea that if a Docker container is just this sort of box, And if I, the software developer, wire up everything inside that box exactly the way I want it, so I install my application, all of its dependencies, I tell it how it should run, then wherever my operations team or wherever I take that box and put it, whether it's on another developer's machine, a server in the cloud, a server in my office, it's going to behave the exact same way. And I have to say, in my year and a half of working with Docker, I have run into problems where things behave differently in different environments, but it is because of a different mistake that I made about how I was configuring the environment and not how I was wiring up the container. So as far as this promise, it definitely delivers, though you still have to keep working at it. So how does it work? I'm not going to go into the low-level technical details of Docker today, but there are definitely links to that in the presentation if you want to learn more. So when people first learn about Docker, they try and compare it to an existing technology that's out there. Some people try to compare it to a virtualization tool like VMware or VirtualBox, where it's this layer that's providing virtual hardware using the computing power of your machine. Some people think it's like a VM manager like Vagrant. Some people think it could be like a configuration management tool like Chef or Ansible. And you may have heard terms like C groups, LXC, libvirt, or Go. And the truth is, Docker doesn't really fit into any of these categories. When you look at the official definition on the website, docker.com says that Docker is an open platform for developers and sysadmins to build, ship, and run distributed applications. And it's sort of broken down into two main components. There's the Docker engine, which is the binary, the tool, the open source project that's running on your machine to provide that container environment. And there's the Docker Hub, which is sort of like the GitHub of the Docker world. It's the place where everyone sort of shares the images that they've built using Docker. But for me, I think the best way to think of Docker is being on a spectrum. So this is sort of a spectrum of configuring a server, let's say. And all the way on the left side are methods that are less portable but have minimal overhead. And all the way on the left side is manual configuration. So you spin up a new EC2 instance on AWS, or you get a new server and take it out of the box in your office. You have to somehow get access to a terminal session on that machine and run all the commands that you need to do to install all of your dependencies, install your application, tell it how to run, all that good stuff. That is a great method when you're working at a small scale because you can run all those commands, and then when you're done, the server's ready to go. But as soon as you try to take that configuration to the next server, you have to do the exact same amount of effort again, and it's very error-prone. So the sort of conventional tool for solving this problem for the past decade has been configuration management tools like Puppet or Chef or Ansible, where you are defining sort of a desired end state for your server using that tool's particular configuration language. So it's an Ansible playbook or it's a Puppet file. And then you can take that configuration and apply it to every server that you want to work on. So when you spin up a new EC2 instance, you can point Puppet or Ansible at it and have Puppet or Ansible do all the work to set up that server exactly the way you want. And this is way better than just SSHing into something and trying to remember all the right commands to run. But it still takes time to apply these configuration changes. So all the way on the right side of the spectrum are configuration techniques that are most portable, that will work the exact same way everywhere you take them, but also have lots of overhead. And that's traditional virtual machines. You might work at a company right now where at the end of your build process, you create an Amazon machine image and then use that to deploy to EC2. Or maybe, I've seen this before, where development environments are so complicated for a business that they use something like VirtualBox or Vagrant, and then as soon as it's done being configured for the lead developer, they just take that whole virtual appliance and like drop it on a server somewhere so that everyone can pull it down and get the exact same thing. This technique is great because you know that that virtual machine is going to work the exact same way no matter where you put it. But it's a really, really, really huge image. It takes a lot of time to build them. It takes a lot of time to move them around. And they have to boot up like a traditional virtual machine, which could take minutes. So to me, I like to think of Docker as being a sweet spot on the spectrum, where you get most of the portability and isolation of a traditional virtual machine, but at a fraction of the overhead. So Docker containers use less computing resources than virtual machines, which we'll talk about in a second. And they also start up lightning quick, which beyond just solving problems for impatient people like me, also opens up really cool new options that we'll talk about later. So if you've gone to docker.com before, you've probably seen a diagram like this. This is a diagram of how traditional virtual machines work. So starting all the way on the bottom, we have the bare metal server hardware that's actually running our computer. Then we have a host operating system layered on top of that. And I'm sorry that's hard to see, but that light gray box there is a hypervisor. So that's the virtualization provider like VirtualBox or VMware. And that's the layer that's taking the computing power from the host operating system and providing virtual hardware that the guest operating systems then consume, so that they think that they're running in their own machine, of course, even though they're not. And on top of that, you have to install the binaries and libraries to support your application, and then on top of that, you have to install your application's code itself. So with Docker, the diagram looks a little bit flatter. We still have our server hardware on the bottom and our host operating system, but instead of a hypervisor layer, we're using the Docker engine. And on top of that, we don't have to worry about installing a separate guest operating system. We can go straight to the application dependencies for our application. And like I said, you can read more about it on the website, but essentially with Docker and containers, the Docker engine is smart enough to leverage the components of the host operating system to provide a guest, what looks like an isolated guest operating system for your containers. Now, it's worth noting that for now, at least in Docker world, this only applies to Linux. So all of the examples that we'll be working with today are on Linux servers. But Microsoft is not to be left behind. They say they are working on a Windows container engine. Hopefully there aren't too many .NET people in this room, but that's coming for you one day. So this is a typical diagram of how a Docker stack might look. So again, on the bottom, we've got the server hardware and then the host operating system and our Docker engine. And sort of a rule of thumb in the Docker world, which you'll get to experience today, is that you want to have one Docker container per process in your stack. So if this was a Django application, for example, that red box all the way on the front might be Nginx doing some reverse proxying for us. Those green boxes could be our application servers. So those might be our Django application being served up by Green Unicorn. And then all the way to the back is our database. And you can see that that green layer can scale horizontally. We could have 2 or 3 or 4 of them if we wanted to, and that's no big deal. Okay, now we're going to talk a little bit about Docker terminology, but you guys are going to dig into this yourselves really soon, so I'm going to keep it brief. There are essentially 3 main terms that you need to know about using Docker. The first one is containers. Everything happens inside a container. Applications run inside containers. Work gets done inside containers. And the main way that you use containers is with the docker run command. So you say docker run, you specify which image that container should be created from, and then you pass it a command that it should run inside that container. And then Docker creates a new container, runs that command inside that container, and the work gets done. So you might be asking yourself, where do images come from? Images are just save states of containers. So you can look at this example, and you'll look at another one in our exercises of the Docker history command, which shows you all the different commands that were used to create a Docker image. And you can see that it's just layer upon layer in the Union file system of different commands being run in different containers creating new images. To speed up the process of creating new images, we use something called Docker files, also known as the Docker builder. So the Docker file is just a series of commands to quickly build an image. So when we dockerize an application, you're going to create a Docker file for it that tells Docker how to create a Docker image for the source code in that repository. So all this might not make a lot of sense now, but you're going to really dig into it in just a few minutes. One thing that I like to mention is that people sometimes call Docker Git for infrastructure, where if Git is a version control system that we use to make sure that our code is the exact same way we expect it to be in every environment we take it to, Docker sort of takes it one step further by actually version controlling the entire environment so that we know exactly what environment we're moving around when we're deploying to servers. So in the Docker world, an image is sort of the same as a commit in Git. They're just save states of the container, save states of your repository. You use containers in Docker for local execution, much like you would a checkout or a clone in Git. A repository is the same in both worlds, and the Docker Hub in Docker is a lot like GitHub, where it's a very popular remote server that everyone uses, but it's not the only one. And in fact, the project that powers it is also open source. It's called the Docker Registry, if you need to run a sort of a Docker Hub internally. Okay, now I'm going to talk a little bit about where Docker came from because I think it's a really cool story. Believe it or not, it was revealed at this very conference, I guess 3 years ago at PyCon 2013. Um, Docker was an open source project from a company called .cloud. If you hadn't heard of .cloud before, .cloud provide a platform as a service business, sort of like Heroku. And there was actually a really interesting New York Times article about Docker maybe a month or two ago where they interview, I think, one of the CEOs or maybe the CTO, and he talks about how stressed he was right before they open sourced Docker because .cloud was not doing well as a business, and they weren't sure what was going to happen. So it's this really cool thing where Docker is this container technology that they were using, the container technology that these platform as a service companies were using to provide their business. And .cloud sort of open sourced that secret sauce and gave it to the world for free, and now they've built a very successful business all around it. So it's a really cool story of an open source company. .cloud officially changed its name to Docker last year, and version 1.0 of Docker was released in June 2014. So that's when all the big red labels came off of the documentation saying, do not use this in production, it is not our fault if things screw up. So I think we're on Docker 1.5 now, and a lot of those early 1.x releases really rounded out some rough edges, which make it easier for you, beginners, to jump into Docker. So we're going to get a lot further today in our 3 hours together than we did at the same tutorial, similar Docker tutorial that I gave a year ago at PyOhio. I think this is a really cool diagram. This is a diagram of Docker partners or the Docker ecosystem from DockerCon last year, I think. And it's just really, really cool to see all the different logos that are on there. There is a good chance that you will recognize some of them as tools you already use in your stack. I like throwing this slide up because it shows how many different companies out there are trying to integrate with Docker to make it easier to use Docker with their tech. For a while, it seemed like there was just a new big announcement every week of somebody partnering with Docker to make it easy to use Docker with their stuff. It started off with the official Linux distros, adding them to the package managers and stuff like that. But of course, the configuration management tools jumped on, the continuous integration tools jumped on, and then all the service discovery and orchestration and stuff like that. So if you enjoy your experience with Docker today and you're trying to take it back to your organization, you should definitely keep an eye out for ways Docker can hook into your existing stack so that you aren't reinventing the wheel on anything. I think this is also a cool slide. This is the timeline of where Docker meetup groups were created all around the world. It's a little hard to see, but San Francisco's that one always on the left, like you might expect. But my hometown, DC, is right there in the middle on the blue graph. But I'm sure yours is up there, or at least maybe a town sort of close to you. And the purple ones are international, and the blue ones are US. So again, if you like your experience with Docker today, I highly recommend you check out your local Docker meetup. There's a good chance that they might be asking for people to help organize, just because Docker hasn't been around that long, so that would be a cool thing for you to get involved in too. Okay, what kind of stuff are people doing with Docker? An obvious first application was development environments. So there was this open source project called Fig, which was actually so popular that it became essentially acquired by Docker and rebranded as an official Docker tool called Docker Compose, which you're going to use today in our tutorial. Fig makes it easy to run multiple containers at once in a development environment. Platform as a service is another obvious application. That was sort of the business that .cloud was in before it pivoted to be all about Docker. There were a few open source projects that were making platform as a services, including mine, which was called Spin Docker, which I think is cooler than any of these names. But what can you do? It's open source. So the first one up there is Doku, which is still maintained as a Docker-powered mini Heroku and 100 lines of bash. So it is functional, but it doesn't have a lot of features, but a cool one to check out for sure. And then the two really big, increasingly mature platform as a service projects built on top of Docker are Flynn and Deis. And if you get to the end of our exercises today, I have some links in there for those if you want to check them out. Continuous integration is another big one. If you have used a service like Travis CI before for an open source project, then you know that by default, when you push new code for Travis to build, Travis will start up a whole new virtual machine to run that build in. And if Travis starts adopting container architecture, which they're starting to do, they have a beta right now where you can use Docker containers to build your Travis builds instead of a VM. It saves money for Travis because Docker containers have less overhead than a virtual machine, but it's also good for you because your builds start a lot faster. So I think right now the configuration command for Travis is you add sudo :false, or maybe that's the one for Circle CI, I forget, but basically, all these continuous integration services are starting to come out with their sort of their options for using Docker containers instead of traditional VMs to do your builds. And you might be surprised how much quicker your builds go, especially because a lot of them are kind of sneaky and don't start the timer on the build until the VM has started booting, which is actually a fair amount of time. So you might not see it in your official like Travis timers, but it's definitely something to look at. Another one, a brand new continuous integration service that's built from the ground up with Docker is called Drone, if you want to check that out too. Another thing people are using it for are educational sandboxes. This is actually how I got into Docker. Like I said, first learned about it at DjangoCon 2013, and I thought, oh, that's kind of a cool tech. I'd like to dig my teeth into that. And then at the time, I was running internal sort of SQL relational database classes at my consulting company. And one time I got really excited because I said, I'm going to go onto my shared web host and provide like a MySQL database for all my students to use throughout the session. So I had to create like 10 WordPress sites just to get the MySQL databases because that's how my shared host worked. And I was really excited going into the class, and then when we got to the exercises, everyone tried to log into their databases, and only one person could get in at a time. And it turns out my web host saw all of these connections coming to backends of my web applications from the same IP and said, this is almost certainly a denial of service attack, and just blacklisted the IP for the office we were in. And that anger fueled me for months to build this website, which is open source now on my GitHub, called DB Conservatory, which lets people just spin up databases using Docker on demand. So that's Spin Docker, that platform as a service I built is what powers it on the back end. But if I was going to update it for today, I would probably use one of those Flynn or Deis, much more robust Docker passes. So all those applications are great, but for most of us, we are looking at using Docker just to deploy our own software applications. So whether it's a web application or some other server client situation, we're just interested in using Docker to solve that problem of it worked in my development environment. And luckily for us, the tools are getting better for that too. So a big one was Boot to Docker, which in version 1.3 added support for Docker volumes, which is what's going to make it possible for you today on your Windows and Macs to use Docker most easily. Another big advancement are the Docker library images, which you will also use today. These save you a lot of time when trying to add a Docker file for for your repository, for your software application, because they essentially come with Python built in, and they come with extra hooks where you don't even have to add a command to install your requirements. It will look for a requirements.txt file and install your dependencies for you. It makes it, you can go from 0 to Docker on a simple Python application in like 2 lines of code. It's awesome. So you are definitely going to use that today. And also there are some GUIs coming into play. Shipyard is one, and then if you were on a Mac, they released Docker sort of acquired a new GUI client last week called Kitematic, which I don't recommend using today just because most of my experience is with the command line, so that's how I'm going to be able to best help you. But if you are the type of person who really likes a GUI, that could be something for you to look at later on. And also, when it comes to hosting your applications, there are some real interesting options opening up. So the whole promise of containers is build once, run anywhere, right? So as soon as I wire up my box, it should behave exactly the same wherever I put it. And this startup out of Techstars in New York called Tutum is trying to make it easy to do just that. You tell Tutum you tell them about your Docker images, you tell them how you want them configured with each other. And then there's literally a drop-down which says, do you want to deploy on Amazon Web Services or Microsoft Azure or Google Compute Engine? And as long as you have the right API keys in Tudum for that, it will go off and create whatever infrastructure it needs on those computing services to stand up your stack. And it's going to work the exact same way no matter what you put in that drop-down box. So I think that's really, really exciting, this idea of being able to move between cloud service providers with much, much greater ease than we used to. But under the hood, what Tudum does when you tell it to go and stand up your stack is it does still go and create, if we were talking about AWS, it does still go and create EC2 instances, so kind of traditional VMs, and then installs Docker on them, and then installs your containers on that VM. There's some new brands, a new breed of hosting services coming out for container-specific hosting. So Amazon has their EC2 container service. Google is doing a Google Container Engine. And like I said earlier, Microsoft is not to be left behind. These services, instead of standing up a virtual machine in these clouds and then installing Docker on that virtual machine, they don't even, they sort of take the virtual machine element out of the equation. So you just tell Google, you tell Amazon, here are my containers, I would like for you to run them, please, and they figure out the rest. So both these are still in beta right now. I did play around with the EC2 container service a little bit, and it seems serviceable, but because it's an AWS API, there's lots and lots of options, and so I'm probably going to wait until Boto makes some really easy bindings for me to use it. But these are probably going to be the way that I deploy my software applications once they get out of beta. And so like I said, Windows Server is not to be left behind. So what's next for Docker? 2014, it seemed like the big focus was getting to 1.0 so that you're production ready, establishing all those partnerships throughout the industry like I showed you on that slide, and rounding out some rough edges which made it harder for newcomers to get started with Docker. In 2015, it seems like the priorities are making Docker even easier to use by rounding out more rough edges and also including some additional tools. Docker also is focusing on popularizing best practices for scaling. So the official red labels came off the documentation in last summer, but people are still just starting to use Docker at scale at these really, really big tech companies. So I'm really looking forward to later this year when we kind of get some war stories back from all of that, and maybe even some new open source projects to help us do a lot of those same hurdles, overcome a lot of those same hurdles. Docker is also focusing on including more batteries. So this is what I mentioned before about sort of building more tools into the core experience of Docker so that you can go from a Docker container on your development server to a Docker cluster in the cloud without having to reach out to any third-party open source tools. You are going to use one of these new beta battery, included batteries tools today called Docker Machine, which is what we're going to use to stand up a tiny EC2 server when you are ready to get to exercise 3. And this has always kind of been a thorn in Docker's side of security concerns. Containers are inherently not as secure as virtual machines because virtual machines think that they're running on fake hardware. It's a very small interface between the host operating system and the guest operating system. Because Docker is trying to be smarter about it, that interface between a host operating system and the container is a little bit more exploitable. If this is something that's really important to you, I would recommend Googling Docker security. You might have to add Jerome Petrazzo, who is kind of Docker's developer evangelist. He did a really great talk on Docker and security a couple months ago, which basically outlines it as it's not foolproof and you can still shoot yourself in the foot if you make some bad decisions, just like anything in technology, which I thought was an appropriate response. So what's next for you? 2 hours of tutorial, that's what's next for you. So we've got 5 exercises, if you count exercise 0, to go through today. The first one is just going to be installing Docker. So you can decide if you want to install Docker on your development machine that you've brought with you today, or you can use one of 50 EC2 instances that I stood up for this class. I have been in lots of PyCon tutorials before where the Wi-Fi is just really bad because so many people are trying to download like Vagrant boxes right now or something. So if you I still think that if the Wi-Fi is being good, that installing Docker on your machine is best because that means it'll save you some time when you try to pick up Docker again later. But as soon as you hit a roadblock, like if the Wi-Fi is bad, if something is just not working on Docker on your system, I wouldn't waste your time trying to troubleshoot the installation because that's not something I'm going to be able to help you a lot with because everybody seems to run into different snags. I would just go and grab one of those cloud servers. So when you look at the instructions for exercise 0, there's going to be a link to that spreadsheet where you can just pick a server and run with it. And I think they're like M2 mediums or something like that, so I'm not skimping you guys with some micros. Exercise 1 is going to be container basics. So that's going to be starting containers and getting used to the Docker command line client. Then we are going to dockerize a sample Flask application. Then we are going to run a whole stack using Docker. So that's going to be a Django application that has a Postgres database and a Memcache service. And then if you get to the end, if you get to exercise 4, which I don't know if most people will because I've crammed more content into 1 through 3 than I expected I would. You can try building your own platform as a service using Docker and the Docker-Py, Docker-Py project, which is the official Python library for using Docker. So definitely don't hesitate to ask for help. Once we get started, I'm going to point you guys at all of the instructions that I've written up for today. I like to think that they're pretty complete, but if you have questions, just raise your hand. And definitely, everyone, how do I want to put this? There were a lot of first-timers in the room, so one thing you may not have realized yet is that PyCon is like the friendliest conference in the world. Everyone here is super, super friendly. This community is awesome. That's why I hustle to put together this tutorial, and I'm doing a Docker talk too. I really, really love this community because it's so friendly and helpful. So there's only one of me, but there are lots of you, and I'm going to try and run around as much as I can, but I hope you'll kind of be friendly with your neighbor and try and help each other out too. That would be really helpful for me. Just a couple housekeeping items. You should take breaks whenever you need them. I think they're going to have coffee and snacks somewhere nearby around like 10:30, but don't quote me on that. I read that email very early this morning. And also, if you haven't downloaded it yet, there's the guidebook app for the conference. This is a kind of a side PSA. This is a really, really useful app for those of you who, this is your first time at PyCon, because when you download it, you can pick the Python sort of conference schedule, and then you can see all the talks and tutorials and every event that's scheduled for the conference, and then you can go through and pick the ones that are interesting to you for each time slot and add it to my schedule. Which is what I use when I'm trying to move quickly between talks on Friday, Saturday, Sunday, and I don't remember which talk I thought was the talk I wanted to go to in that time slot. So it's really, really useful just for that. But the reason why I have been asked to plug it here is because there's a survey link at the bottom of this session's entry in the guidebook, which is a feedback survey on this tutorial. So I'll try and remind you again at the end, but when you leave, please fill out that feedback survey because I'm going to give a very similar tutorial to this at O'Reilly's OSCON open source conference in July. So if something wasn't working out for you in this tutorial, I would really like to hear it so that I can help people out next time. And you know, I'm a tough guy, so if something's really bugging you, you can just come up and talk to me. I can handle it. Okay, does anybody have any questions on all that stuff before we get started? But this will most certainly not be your last opportunity for questions. Yeah.
So you can't run it on Windows, but I noticed that OS layer can actually mix OSs.
Like Debian and Ubuntu or something like that? Yes, totally. Yep. So the question was, could I run multiple Docker containers on the same host? Say like the host was Ubuntu and I wanted to run a Debian container or a CentOS container or something like that. The answer is yes, and you'll probably end up doing that today. I don't remember which distros I built my containers off of, which is the crazy thing about Docker is that it's almost not important anymore. Any other questions before we get started? Okay, cool. I'm really excited. This is my favorite part. I hate the talking part at the beginning. I like the helping people part. So this is the URL you need to go to, and this is where all the instructions are. So it's docker.atbaker.me. And once you get there, there's going to be some intro text. which sort of describes my philosophy on these tutorials, which is not to give you all the answers, but to give you half of the answers and then point you towards the documentation so that you can find the rest of the answers yourself. Go ahead and get started. I will be hanging out up here. If you get stuck and want a hand, just raise your hand and I'll come on over. Thanks, guys.